Hello guys, we'll look at a simple example in this video. It's very simple. I'm sure you have already done similar types of equations. Right. In this example, we're gonna look at two particles here, particle P and particle Q, and both of them have velocities with respect to a fixed point or with respect to Earth. So Earth is not moving. We are moving on Earth. Actually, Earth is moving, but we don't feel it since it is relative to us. Uh, we take it as fixed, a fixed frame. So the velocity of p, we no longer represent it with a single quantity. So velocity of p with respect to Earth, we can either use O or we can use Earth here because Earth is not moving and O is located on Earth. So it says that it is in this direction 100 meters per second in this direction. So wait. And velocity of q with respect to Earth, velocity of q with respect to Earth would be, it is given as 200 meters per second in this direction. Right. So you asked to find how fast q is with respect to p, or how fast p is with respect to q. So we can find it like using the equations of relative velocity. Relative velocity of q with respect to p is given by this equation, velocity of q with respect to Earth plus velocity of Earth with respect to p. Right. So notice here that the directions are given here. So these two are in opposite directions to each other. Now q of p, vq with respect to E is 200 meters. 200 meters in this direction. And EP, what is Earth with respect to particle P? So since particle P with respect to Earth is moving in this direction at 100 meters per second, the Earth is moving in the opposite direction with respect to P. I know it doesn't make any sense, but this is how relativity works. So it will be in this direction 100 meters per second. Now since both vectors are in the same direction, so we can add these up like you do with real numbers. So the answer is 300 meters per second in this direction. So if you go ahead and find velocity of p with respect to q, you would find the same answer in magnitude but different in direction. So this would be 300 meters per second but in this direction. Why? Velocity of q with respect to p. So if you are at p, you would see that q is coming towards you, right? And that is represented by this vector. If you are at p, if you are observing, if you are at q, yeah, and you are observing p, then you would see that p is coming towards you in this direction, right side. So this is represented by this arrowhead. See how simple this is. So this would be a bit complicated when it comes to motion that takes place in two dimensions. But as long as we are sticking to one-dimensional motion, then it is easy to deal with this vector representation. So when it comes to two dimensions or three dimensions, you can have to use unit vectors. That way it is easier, or you can use graphical methods to solve problems. Now let's say that what about the acceleration? So acceleration, suppose acceleration of particle p and acceleration of particle q, acceleration would be 2 meters per second in this direction, and here acceleration. be meters per second in this direction. So at time t, if you take a snapshot, particle p would be here and particle q would be there, and at that point the velocities would be 100 here and 200 there. Of course, with time the velocity will change. So if you are looking at the if you want to calculate the relative acceleration, you can use the representation given acceleration with respect to acceleration of q with respect to p can be obtained by acceleration of q with respect to earth, which is given there, plus acceleration of earth with respect to p, right? So acceleration of q with respect to p would be acceleration of q with respect to earth is 3 meters per second in this direction, plus earth with respect to p would be in the same direction, which is 2 meters per second. Right, so the answer is 5 meters per second. You can see here that with respect to a fixed point, the acceleration of these two are 2 meters per second and 3 meters per second, but the relative acceleration is much higher. It is the addition between these two values. So you would see that the rate of change of the velocities would be much higher relatively, right? But to a fixed point, it won't be that much high. Okay, so thank you for watching, and we'll see you guys in a difficult, more of a hard example in the next videos.